It's a lot than any other unit, but here we go. Intro to sets. So this is chapter 3. Some of the definitions. We will often call or make reference to the universal set, and we use the letter U for it, and refers to all possible elements that could be considered for a certain set. It's also called a sample space, but 99% of the time it's the universal set. So it's kind of like setting the parameters, the boundaries, the box from where you pick. Okay, so for example, if I wanted to make smaller groups out of me saying this class of grade 12 applied section 2, we're talking about the 30 students that are in this class. That would be considered my universal set. Okay, it's kind of defining clearly what can I pick from. In this case, it would be this class. You could also define it as Sisler High School, students from Sisler High School. So right now we have 1,700 or more students. That's where you would pick from. Okay, capital letters are used to name sets or subsets, and must use braces to open and close the set. So what kind of braces? It has to be specific. So for example, you could say set A is equal to, and then you go, these are the braces we use. We call them the squiggly brackets. Maybe some of you know them as the squiggly brackets. So there could be stuff in here. A set, a collection of objects that have something in common or follow a particular rule. Element, the objects in a set are called elements. Okay. Note, every element must be unique, no repeats. So this is very important. Every element must be unique, so there are no repeats. Maybe I'll use a different color just to, no repeats. And it has to be arranged. Okay. Either alphabetical or numerical. Okay, so that's important. That is a must when you state a set. Okay. So you could have, let's say that E represents this set with all even numbers, and you would say, well, it's 2, 4, 6, 8, and then we go comma dot 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 and close it like that. So that's all even numbers, right? E is all even numbers. So we have defined the set, we call the set E, and all of these are the elements, right? So these are actually the elements. And the elements can be anything. It could be words, it could be, like, let's say you call it, animals with four-legged animals, let's say. Four-legged animals, so horse, cow, like you would put them in there, so those would be your elements. Morning. That ever happens. That's if you want the video. And so then we have a set, then we have subsets. Okay, it's a set within a set, right? So I think that's important to highlight. And here's the another definition is all the objects belong to a greater set. Right? And the notation we use is that symbol right there. Looks like a C, but it's a bit longer than just a C. So A belongs to B, right? Means that all the elements of A can be found in B. I would underline all the elements of A can be found in B. In a Venn diagram, subsets are drawn inside a set. Right? If even one element in A is not part of B, then we write A is not a subset of B. So for example here, when you look at set A and set B, how do we know those are sets? They have capital letters. And then you have all the elements in there. So when you compare, you look at blue, there's blue here, right? So blue and blue, so far we're good. Green is also in B. Red is also in B. So in this case, we could say that A is a subset of B. Why? Because every single element that is in here is also in there. Okay. They have more. B has more elements, but we know that all of the ones that are in A are also found in B. So we would say like this. We would draw it like this. A Venn diagram always has a box. Okay. And in this case, set B is a bigger circle like this. And set A would be found inside of that set B. And so the ones they share in common, this, sorry guys, this is small, I know. I'm going to zoom in a little bit. I should have made it bigger. Blue, green. I'm in trouble here, guys. I'm going to have to redo this. I need to have enough room for blue, green, red. I'm going to do it one more time. Blue, green, red. And my camera is not cooperating there. Blue, green, red is inside A, and the other two colors, right, black and purple, are part of B, so they would be over here. Black, purple. Okay, so that's how you would sketch it. So if you look at it in the big picture, these three colors, right, are part of B as well. Okay, so A is a subset of B. Okay, however, but B is not a subset of A. You have to know that B is not a subset of A. You cannot say that. You cannot say that every single element in B is found in A. It's only one way in this case. Did you notice that they're arranged? That may not be obvious to you at first glance, but I arranged them. Okay, so just so you know, that's by definition, the elements have to be arranged. So if I ever ask you what's wrong with this set, and you notice, hey, it's not arranged, that'll be one thing that's wrong with it, right? Maybe it's just that, maybe it's the notation. Okay, next, n of x. If you see this, if you see the n, right, it means, why do I have this? Anyways, just focus on the n of x. That means the number of elements belonging to x is. So let's just make up a number. If you see n of x is 8, right, that means that the number of elements belonging to set x would be 8. That's really what that means. That's why I had it there. Okay, so let's say n of x. So that really would mean this. Let's just come up with numbers. 1, 2, 5, 9, 11, 13, 17, 22. How many do we have? 2, 4, 6, 8. That is 8. Okay. So we're done. That's just an example. I could use words that would just take us longer, right? I could have different colors, different names of students, whatever. So I don't want to pick names from this class because then you're going to think I like them more than somebody else, right? You don't want to have favorites, right? Never have favorites. Right? Like all your children, right? Infinite set. Okay, if a set starts and ends with dot dot dot, it indicates an infinite set. So, for example, here you can tell that there are some numbers that should be way to the left and some that are to the right. So this is infinite. So n of d is infinite. You can't really tell how many number of elements are in there because of the dot dot dot, right? It indicates it never ends. Okay. Finite sets, if a number is right, if the element is finite countable, then obviously we say the set is finite. So watch this, right? If you have 1, 2, 3, 4, 7, 9, and then dot 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 49, I did not mean to do that because these are all the odd numbers. You notice that 1, 3, 5, 7. So it's saying all odd numbers. K would be this. All odd numbers from 1 to 49 inclusive. I just defined what would be in here. Okay, sorry, I need to zoom out. um, we'll just leave it at that. Empty or null set. Right? Empty or null, both of them mean the same thing. I'll highlight that. There are no elements in there. Okay, so it's empty. The symbol for empty is either that circle, right, crossed out, or just two brackets like that with nothing in them. Okay. For example, a set of odd numbers divisible by 2 would be an empty set. Okay. No such number exists. Outliers. Okay. That's important too. Elements that are part of the universal but not part of any other set. And you know what? I need to give you a diagram would be best, as a Venn diagram. So let's say you have a Venn diagram like this, and let's say all you're drawing is the even numbers from 1 to 10 belonging to this set. So that'd be 2, 4, 6, 8, 10, like that. The universal, we usually put it out here. That's the box, right? So let's say you have numbers 1 to 10, and set E is your even numbers. That's all you have. So you make a little circle and you state all the even numbers. So out here would be what? The odd ones, right? So it'll be 1, 3, 5, 7, 9. These would be considered the outliers in this case. Okay. Unless I would make a set called O, and I put all the odd numbers in there, then I would have a circle called O and put all these ones in there. But in this case, I didn't. So this would be considered the outliers. Okay. Okay. Let's keep going. Where are we at here time-wise? We're doing okay. Equal sets. Two sets that are said to be equal if they contain the exact same elements. Okay. I think I'm not going to spend a whole lot of time on that. A is a set whose numbers are the first four positive whole numbers, so 4, 2, 1, 3. What's wrong with this right now? It's not arranged. Right? So B would actually be 1, 2, 3, 4. That'd be the correct that's arranged now. So there we have it. And A is the set of whose numbers are the first four positive numbers. A is technically, they defined it with words, but it's the exact same set. Okay, A is equal to set B. And if I ever asked you for this, n of A, what would you write down? If I actually gave you this, what would you say? If it's n of A, we would put down 4. Because the n is asking him how the number of elements in A is 4. The number of elements of B is also 4. So if I ever asked you that, you could say that. So these are exactly the same sets. We would not say subsets in this case. We just say they're exactly the same. Okay. You're liking the definitions, don't you? I feel your pain, guys. I feel your pain. Disjoint sets, two or more sets with no elements in common. Okay, two or more elements with no elements in common are said to be disjoint. Here's another word. I'm going to use a different color for this one. Disjoint sets are also called, this is going to come back later. I'm going to highlight that with a different color. Are also called mutually exclusive. They're excluding each other. They're not including each other. For example, a set of even numbers and the set of odd numbers are disjoint. Okay? This is how you graph a disjoint set. You can just put it there. But we would call U would be even, O would be odd. I'm just gonna I'm gonna use negatives as well. So -2, 0, 2, 4, 6, and so forth. And odd would be -1, 1, 3, 5, and so forth. There's nothing in common here. There's no overlap. Okay? No overlap. Mutually exclusive. Joint sets. It's the opposite of disjoint sets, right? Two or more sets with at least, right? At least one element in common are said to be joint. Venn diagram has an overlap. Okay, Venn diagram has an overlap. Example, a set in which students taking grade 12 applied are also taking biology 40S. It could be that, right, there's a student that takes both. Anybody taking bio 40S? Yeah, I was really hoping for that to be the case. So, okay, we're gonna call this A and B for applied and bio. It just worked out perfectly that way. Only 3 students taking bio 40S? Nicholas, Hannah, and Gabby? Oh, you're taking it too? It's too many names to fit in there. But anyways, you get the point, right? So I'm going to go with Nicholas, Hannah, Gabby, and Danica, right? 4 students taking both. So you're like, wait a minute, how does that work? Well, these 4 students would be part of this set and would also be part of this set, right? If both classes, if I took the attendance and Miss, I'm just gonna say Sankovic, right? If she takes attendance and we're like, hey, we have 4 in common here. It's like, okay, so the Venn diagram would look like this, right? 4 elements would be in common. All right. Complement is very important as well. Every set, subset has a complement. Has? Supposed to say has. I'm very sure I made a mistake there. Can you add an H? One more thing I need to go back and change. Those that know me, you know I make mistakes, right? So sorry, guys. It's denoted, right? Denoted by using either that little apostrophe or a little bar above the letter. Okay. So let's consider set U. This is what you have to pick from, guys. This is the universal 1, 2, 3, 4, 5, 6, right? You have 1 to 6. So if you roll a die, for example, your universal is 1 to 6, right? That's all you have to pick from. And so if even is 2, 4, 6, then not even, right? I would say this is even. And as soon as you have that little apostrophe or the bar, this is not even. And what do we call not even numbers? We call them, we actually have a name for them, odd numbers, right? So it's just a different way of looking at it. So in this case, if 2, 4, 6 belong in this set, the ones that aren't in this set is what you state over here. So you would go 1, 3, 5, squiggly brackets, close. They're both finite, okay? We have the limited number to pick from. So I will just say odd. I think we're going to draw the Venn diagram first here, based on this, okay? So you make your box. That's what we call the universal. In this case, it means numbers 1 to 6. Are these joint or disjoint sets? Will they overlap? They don't overlap because if you look at it, these two have nothing in common. In fact, you actually, by saying not, it means they're not going to be joint, right? So this is even. And let's go even not like that. So this would be 2, 4, 6. This would be 1, 3, 5. In this case, there are no outliers. Every number that we had to pick from the universal belongs in each one of these subsets here. Okay, note in general, NE plus N not E is equal to the universal set. If you think about it, in this case, 3, I don't want to do it in here because this is just your general formula, right? But the number of elements in here plus the number of elements in there will equal the number of elements in the universal every single time. Okay. I think I'm going to stop there. That's it for today. No homework. Thanks for listening. We'll continue and pick up tomorrow. What you could perhaps do is already on your study sheet, add the definitions, right? But make them short. Don't make them too long, right? You just want to have a concise way of referring to it because this comes back all the time, right? Thank you, guys.